now. Okay, so for the most part, it's just a very, very quick minds-on. I am going to take us into chapter 3.3. That's a bit of a detour to all the exponential functions we've been doing. Just to give you a heads up of where we're going, you'll understand, or you would have expected this if you've been keeping track of our monthly schedule, the Google Doc, the Excel sheet that we have. Um, Functions involve fractions. Functions involve positive exponents, negative exponents, zero exponents. But if those numbers are possible, then of course we could also have fractional. Not to scare anyone, but today my goal is to let you know what fractional exponents are. And in doing so, I'm going to provide some like puzzle-like questions where you apply all these different exponential laws, exponent laws, to simplify. The goal is to be comfortable with exponent laws. That's the stuff that you see here. I should probably turn on my video. Okay, it's the stuff that you see here so that you can apply it to questions where you have a base value, like a 2 or a 3 or a 4 or an 8 or whatever, and simplify it. If you can simplify, well, it just makes your life a lot easier. I hope that you'll be able to put some time in and get yourself comfortable with these things called rational exponents or fraction exponents, basically, ratio exponents. Okay? I think I already talked to you about the transformations assignment in class on the Friday, so I don't have to go repeating it. But the test, because I believe I have made the review section available online, maybe it's a good time to talk about the test. I didn't talk in detail about the test, correct?
No.
Yeah, okay, so we'll talk a little bit about things. Um, Helen, I believe you're joining us for a bit, but this is actually my E1 and E2 class, so you don't have to necessarily be. You'll see this lesson tomorrow, but you are more than welcome to stay. Okay? So just to recap, this is my E1, E2 class. So no, don't be. It's totally up to you if you want to stay. You're getting a heads up of what's to come in the first half of tomorrow morning. Okay, bye. All right, here we go. Quick minds on. I'm hoping you get a chance to take a look at this. Very simple, very quick, but some of you might have just memorized this in grade 10, and that is not going to be enough. I really need you to sort of understand where it comes from. And even if you don't remember where it comes from every single question, that you know where the shortcuts that you might have memorized also come from. Okay? Quick. Someone who remembers from grade 10, what is the answer to the first portion? Someone who remembers from grade 10.
X to the 5?
It
Really?
is
X
X to
to
the
the
5.
5.
Yeah, absolutely. How did you get that?
You add them?
Well, yeah, so you 2 plus 3.
You add the two. Go together.
Why? That's the million-dollar question. Why, though?
Because it's actually never mind. I can't really explain it.
All right.
Yeah, like it's like kind of like X times X, and then the other one
Mhm.
like X times X times X, so it's just 5 X's basically.
Yeah. Exponents, if you didn't know or you forgot, is simply a way of writing that the same base is multiplying with itself again and again and again. So, if x to the power of 2 is here, and I'm multiplying with x to the power of 3, which is here, that's essentially the same as saying x is multiplied by itself 5 times. And oh, is there a coincidence between the exponent here and the exponents that we have over here? Well, the answer is yeah. And so as opposed to writing it out, right? I always say this from the get-go, mathematicians are the laziest people in the world. Why would I want to write it there if I could just remember, oh yeah, the exponents simply add. Okay. Now from here, this is actually the beginning of all other exponent laws. Can't even read that, but you get what I'm saying. So if you understand this and logically understand this, all the other ones I can play out naturally. So here's my appeal to your logic. If if multiplying exponents of the same base makes you add the exponents, add the powers rather, sorry, what logically would you assume if I'm dividing exponents?
Subtract them?
Subtracting. That's absolutely right. So if this is the case, x is to the power of 2 minus 3, which means I should get x to the power of -1. Does that make sense? It's like, what? That makes no sense. No, well, it does. Let me argue otherwise. X to the power of 2 is the same as x times x. X to the power of 3 is the same as x times x times x. So essentially, I have x times x dividing by this numerator, right? And any number divided by itself is 1, right? 5 divided by 5, 1. 10 divided by 10, 1. 100 divided by, it's 1. So anything divided by itself is going to give you a 1, 1, which gives me 1 over x. And if you remember our lesson from negative exponents, these two are equal to each other. So far, so good? Any questions? Yeah. So, quick recap. Remember, this is all exponent laws, and you can only use them when they have the same base. So, under the context of same base, if you are multiplying, the exponents will the powers will add together. If you're dividing, the powers will subtract together. And another way you can write that is this, right? X to the power of 2 divided by x to the power of 3 is the same as taking 2 minus 3. All right? Next. The same idea, logic can be applied when you have a power of another power, a power to another exponent. Exponent inside an exponent. And you want to remember what you're supposed to do. 310. Going once.
You multiply the
Oh
two.
yeah. It becomes x2 times 3, which is a 6. Claire, would you be able to explain why?
Because you have x times 2
Mm-hmm.
3 times.
Essentially, that's x times x
Yeah.
multiplied by itself, correct? Multiplied by itself. And so if I were to, assume the brackets were not there because it's all multiplication anyways, how many x's do I have? 6. Oh, is that a coincidence? No. So if you have a power of a power, instead of writing it all out, mathematicians being the laziest people, we can just keep in mind that, oh, a power on top of another power, we just multiply it. Okay? The same can be said about when you have a fraction. It doesn't mean the rules change. Claire, you want to take over? What would the fraction here as a base turn into?
Isn't it just x over y to the power of 3?
Like this?
Yes.
Careful. If you're wondering, let's write out what you told me up here. This is the same as x squared over y squared multiplied by x squared over y squared multiplied by x squared over y squared.
Yeah. So it's x to the power of 6 over y to the power of 6.
Yes.
But isn't that like before you do the exponents? Are you allowed the exponent 3? Are you allowed to just like square root the x squared and the y squared?
You could, but why are we square rooting? There's nothing on the other side of the equal sign. Like if you square root, you gotta square root the other side, right?
Oh, okay.
I'm just simplifying. I know what you're saying now. I get it now. It's just a quick simplifying question. It is not trying to solve for something. Okay. So again, if you have, exponent to exponent, same idea. You apply it to everything inside the bracket. The same can be said. What if I gave you how about this? What if I gave you like 2x negative 1 y squared over 3? What about that? You know what? I'm gonna make some more space. I'm gonna make some more space. I don't need to see my face here. I'm gonna clear that. Okay. Let me erase this. What if I wrote 2x to the power of negative 1 y squared all to the power of 3? Nothing changes. Someone want to give this a shot, and I invite you to be wrong. It's okay. It gives me an opportunity to explain to the class. Give it a shot. Anyone?
I can try.
Yeah, go for it.
I have one problem though, is I wouldn't know. I totally forgot what x negative 1 to the power of 3 would be, but I feel like I know the other one.
Okay, go for it.
So would it be 6? So you do the 2 times or 2 to
Mm-hmm.
the power of 3,
Okay.
which would be, well, I guess that would be 8.
Yes. Oh, I thought you said 6. My bad. Yes, that would be 8.
So 8x something and then y to
Mhm.
the power of 6.
Good. So in case
X
people
to the
were
power of something,
wondering,
y to the power.
yeah, in case people were wondering why it became an 8, remember, even regular numbers have an exponent of 1. Like, if I had 2 to the power of 1, that's equal to 2. So why would I add an extra 1 there if I could just write 2? It's one and the same. But when we're dealing with exponent laws, well, it'll be nice to know what the exponent actually is. So if it's missing, assume a 1 is there. So what is 1 times 3? That is 2 to the power of 3. Negative 1 times 3, x to the power of negative 3. And 2 times 3, y to the 6. And this becomes simplified into 8. The negative 3 tells me I can do the reciprocal. That becomes my final answer. Right? So this, if you remember, would become that. Yeah. Soak it in. Soak it
Uh,
in. Question?
um, if you multiply and it's just x to the negative 1, do you
Mm-hmm.
always just do the reciprocal and basically put it as the denominator, but positive?
Essentially, yep. And if you have 1 over x to the power of negative 3, if we go through the motions of calculating and everything, it does become that.
But stays on the denominator.
Okay?
Like it's a denominator, not a numerator. You know what I mean?
Yeah, well, right now it's in the top, it's the numerator to the power of negative 3. It will end up as a denominator with a positive exponent. If the negative exponent is on something that's in the denominator, you can assume that it just moves to the numerator with a positive exponent.
Okay, thank you.
Okay? Okay. And this, any questions here? Because again, we're just going through the exponent laws, but this also and this together, everything sort of starts to pile on together. It's a little difficult to just memorize sometimes, but you're going to have to practice it. And all of the stuff we've talked about just now brings us to how we can solve rational exponents. So once again, any questions with how to do these exponent laws? You think about it. While that's happening, I'm going to mark Aiden as present. I see him. Do we also have Abby, or is she still missing? Abby? Going once. Hope she's okay. Alright. Alright. Allow me to erase a bunch of this and bring the $1,000,000 question to the top. Oops. Oops. Right here. To answer this now, I want you to consider this question. This is for everyone. I'm not going to ask you to answer it unless I know that you. I just need you to walk with me through it. Who else is there? 2 times 2 equals someone. Let's go from the bottom up. Will. 2 times 2.
4.
Right on. Okay, so if this is true. Sydney Kendall, would you also agree this statement?
Yeah.
Yeah. So here's my argument, everyone. So I don't know if you see me by video, but I'm just like trying to gesture here. I'm being frantic. If this is equal to each other, then we can automatically assume that these two are equal to each other. Okay? Sydney F, would you agree? Yes, great. All right, so if that's the case, then we can say, well, that makes sense, right? We know what the square root of 4 is. It could be plus minus 2, but for the sake of argument right now, let's just pretend it's a positive 2. Okay, so, Sydney, Monica, would you also agree that 4 is actually the same as 4 to the power of 1? Would you agree that all three of these lines equal the same number?
Yeah.
Yes. Okay. That means, remember, if we follow our exponent laws, something multiplied by something of the same base must give me 4. Let me reiterate. 4 to the power of something times 4 to the power of something gives me an exponent or a power of 1. Ooh, everyone, I want you to think about that. 2 times 2 is 4. You got that. Root 4 times root 4 is 4. You got that. But if this is true, and the statement 1 is true, and then statement 2 is true, to make or to fit the exponent law in here, what must the exponents be? What plus what must equal 1?
Half.
Half. Is there any other possibility? Is there any other
1 and
possibility?
0.
It could be 1 and 0, but remember, these two numbers have to be exactly the same because these two are the same and these two are the same, so I'm assuming these two are also going to be the same. Right? So again, my argument is I'm writing the same statement in 3 different ways. Right? So whatever this number is and whatever this number is, it has to be the same because these two are equal each other, and 2 and 2 obviously equal each other. So is there any other combination of numbers that add to 1? Like 2 and negative 1 are not equal, but yes, they add to 1. I need these two numbers to be identical. Are there any other combinations that we have? Going once, going twice. I personally think there are no other possibilities, which means if 2 is equal, 2 times 2 is this, and root 4 times root 4 is equal to this, and we made it clear that 1 and 2 is equal. Well, following the exponent laws, we also need to consider that this is equal to 4. This is also equal to root 4. So 2 is equal to root 4, and root 4 is equal to 1 over 2. And this is rational exponents. Okay, no, that's fine. I'm glad you're here. I just got to change your attendance. Everyone, just take a look at what I wrote and let that sink in. A square root, sorry, 2 is the same as the square root of 4, and that, by argument, is also equal to 1 over 2 as an exponent. Show of hands, who is okay with what I just wrote? Who's comfortable with what I just wrote? We got like a couple of people. Everyone else, I guess they're just soaking it in. We just use our calculators if the exponent is a fraction. Yes and no. There will be situations where I might ask you to do it without a fraction. But you'll see what I mean. It's just an exercise. On a test, obviously you have your calculator with you. But knowing how to manipulate exponents is going to be important. So I'm just trying to show you, not to be afraid of fraction exponents. Okay? I didn't get too much of a response, but that's okay. I don't expect this to come naturally to a lot of people. Here we go. So this is it. When you have some base, x over, let's do it y, okay? The top exponent is just a normal exponent, something that you've done all this time. When you see a denominator on the exponent, you could assume that is basically the same as a root. So, for example, if it's 4 to the power of half, that is the same as a second root or the square root of 4. If it's 1 over 3, you can say it's the third root of 4 or the cube root of 4. 4 to the power of 1 over 4 is the same as the fourth root of 4, so on and so forth. Okay? So, I'm not going to go into the 8 to the power of 2 over 3 yet. Let's do this. 8 to the power of 1 over 3, now you know, can be rewritten as the third root of 8. What multiplies with itself 3 times to give you 8? Something times something gives me 8. What is that number?
2.
2. That's right. And please note, just for the puzzle type questions that I give you in the future, it might be a good idea to recognize multiples of powers of 2 and maybe even powers of 3. Like does everyone know that game that was popular like a year ago, like 2048? People know that game?
Yeah.
Yeah. So what happens? You start with blocks of 1, and then you mash them together, it becomes blocks of 2, and then you mash them together, it becomes blocks of 4. You mash them together, it becomes blocks of 8, and 16, and 32, 64, 128, 256, 512, and then 1024, and then 2048. These are all exponents with base 2. Some of these numbers you might also recognize if you're a bit of a techie. So back when I was a kid and internet was still sort of relatively fresh, and the idea of computers was huge, like Windows 1998 came out and everyone, like, mind was blown, okay? The typical hard drive back there was not even 1 gig. It was like 512 megabytes or something like that. And people were like, whoa, your computer is amazing. That's funny because, the typical video game app that you might download is like 500 megs nowadays. But when someone says it's like 500, your hard drive is 500 gigs or 500 gigabytes, it's actually not 500. It's actually 512. Computers are built in a certain way or a certain system where it uses powers of 2 to increase in capacity. So if you know about video cards or if you know about electronics, you might have a video card that was like, oh, it's 4 GB of GPU, blah blah speed, gigabyte speed or whatever, or something like that. It's all in multiples of 2. Okay, so at least for multiples of 2, I hope that you'll be able to find it, be familiar with it, or just be comfortable with it, so that when I give you something like, what is the terabyte? Same thing. 1 terabyte. 1 terabyte is basically 1,000 gigabytes, right? And which is the same as 1024000. You could think about it like that. It's actually this many gigs. And it just keeps on growing in that way. It's always growing in multiples of 2. So, anyways, I'm digressing. So let's talk a little bit. Now that we have 8 to the power of 1 over 3, and you have an idea of what the denominator is supposed to represent, okay? What if I gave you something a little bit different? 8 to the power of 2 over 3. It might throw you off a little bit, but remember, I'm going to actually apply an exponent law of a power of a power. Would you agree that this makes sense? Okay. When you have a power of a power, you can multiply. And what does 1 over 3 times 2 over 1 equal? That's 2 over 3. So this and this, I can argue, are equal. Why am I separating it? Well, it makes life easy. What did we establish was 8 to the power of 1 over 3. You do the cube root of 8, the answer is 2, and all that's left is to do an exponent. The answer of 8 to the power of 2 over 3 is 4. That's essentially it. Okay. Any questions? Because I'm going to throw something at you.
Can you explain that one more time? Sorry.
Yeah, sure. Let me clear this. Let me give you another example. You know what? We can do a question that I assigned earlier. Yeah. Number 5D in the sheet that I gave out to the class online. 32 to the power of 3 over 5. Now this can be rewritten as 30 to the power of 1 over 5 and to the power of 3, or 32 to the power of 3 and then 1 over 5. Why was that? Let me remind you of this exponent law. When there's a power of a power, exponents multiply to give you 6. In the same way, what if I had x to the power of 3 over 5? You can say that it was from a 3 here and a 1 over 5 there. I'm multiplying this. Does that make sense?
Yeah, that makes sense.
So anytime you have a fraction, you can break it apart. The numerator is just a regular normal exponent that you know of. The denominator is a root. The question is, which one do you want to do first? So I'll ask you this. Do you want to do in your head, because I expect you to do this in your head without any calculators. Do you want to do 32 times 32 times 32? Or would you like to use your brain to figure out what multiplies with itself 5 times to get 32? I'm hoping everyone establishes that this is too hard to do in your head. So 32 to the fifth root of 32 is actually 2. That is to the power of 3, which gives me 8. 32 to the power of 3 over 5 is equal to 8. Questions? How are you with that? Yeah.
Wait, sorry.
Yeah.
So are all of these a root of 2?
Not all of them.
Because
Not
like
all of them.
what if you found a number where you couldn't, do the whole square root thing?
Well, for our purposes, I will also give you something that you can root with. Here's one. Number 5C. How about that one? What do you think? Remember my example here. When you have an exponent, it applies to everything, so it becomes 6 to the power x to the power of 6 and x to the power y to the power of 6. In the same way, I am doing the cube root of 1 and I'm doing the cube root of 3. So this is just 1 over 2. What do you think? Questions? All right. That's a lot of fractions. Let's backtrack and just get a little bit more comfortable with exponent laws. Here we go. Number 3C in your sheet has this. And I'd like you to try it. Give yourself maybe a couple of minutes for each question and solve it. And number 4A has this amazing question. So amazing. There. All of them, they're not fractions. They're just regular exponent laws. Let's see what you can make of it. And then we will try one that has an exponent. Sorry, it has a fraction in the exponent together. Okay.
I
Take
have a
5.
question.
Yep.
When you try to solve these, do you just simplify or do you actually like solve for the answer?
Simplifying is all I'll ask. I won't ask you to actually calculate everything if for like a test question if I do ask something like this.
Okay, thank you.
Okay. My goal is to see if you can apply the exponent laws. It's maybe another 2 minutes. Be right back. Okay, someone want to take over? Tell me what you got for the first one. Just take a guess, I guess. I don't expect everyone to catch on right away without practice, but someone want to see if their answer is correct. Be brave. You're not embarrassing yourself.
I can try.
Josh, you gave me so much today, but okay. Go for it, Josh.
Okay. So 2 to the power of 5, then to the power of 3, I got
Mhm.
8 to the power of 15.
Did you say 8? Sorry, say that again.
Yeah.
8 to the power of 15?
8 to the power of 15.
Oh, careful. When we do
Yeah.
exponent laws, the base doesn't change. So it will be 15, but we'll keep it 2 to the power of 15.
Oh,
You know what
okay.
I'm saying?
And then
Yeah.
yeah. Okay.
And
And
then?
then I'm looking. And then 2 to the power of -4.
Good.
And then over 2 to the power of 16.
Right on. Okay. Now we got, again, the same base. 15, -4, 16.
Oh darn.
It's okay. No, same thing. We got 15.
2 2 to the power of 11.
Good. And then 2 to the power of 16. And so 11 minus 16 is 2 to the power of -5, or we could just leave it as 2 to the power of 5 down here. That's it. The next one, I'm going to go at it because it might look really, really funky. Okay, I have an exponent. So I have a power of a power. So those those powers, sorry, are going to be multiplied with each other. You would get 12 plus 6a. Same thing here. The 4 and the a1 are powers. So 2, 4a minus 4. And this is 2, 6a plus 4. Okay. And again, I have the same base. So the exponents, so the powers rather, are going to add. 2, that's 6 plus 4a, that's 10a. 12 with the minus 4, that's a positive 8. That is all over the denominator. And again, the bases are the same, so this time the exponents are going to subtract. 10a minus 6a, 4a. 8 minus a 4, there it is. That's the final answer. Any questions?
I have a question about that answer.
Mm-hmm.
Could it also be like, could you factor out a 2 and then make it 4 to the 2a plus 1?
4 2a plus.
Oh, wait, I mean
Oh, you mean like this?
4 to the 2a plus 2. Yeah.
4 to the. So the reason why we can't do that is because exponents are very different from the coefficient. So a multiplication of 4 is very different from having a power of 4. Very different scales. So let's leave the exponent alone, as is. You don't have to factor that if you don't want to. Like that. You can do that. That's as far as you can go for factoring. Let's see. Yeah. One last thing I want to show you before we call it a day. Let's see. Yeah. And then I'll have a couple of announcements for tomorrow as well as a test coming up. Sometimes, you might have guessed, I don't give you all the bases that are exactly the same. However, typically there's going to be a trick to it because, of course, these are puzzles. I might ask you to do something like this. So in the front of the sheet I gave you a multiplication of two exponents with different bases. Well, you're stuck. You don't know what to do. However, you might notice that the base 8 and the base 1 over 4, they can both be rewritten to have the same base. So the question said simplify. You can simplify this. So normally it's like, no, I'm stuck. Sorry, I can't because different base. Right? But if you look a little carefully and see that there is a trick to it, you might be able to write 8 as a power of 2. Okay? And the 1 over 4, I'm going to turn it into a 4 to the power of negative 6 because, I did the reciprocal. And the 4 can also be written as an exponent with a base of 2. Someone want to venture a guess very quickly? Let's see. Daniel, you with us?
Yeah.
Yep. Can you
Um,
turn the 8 into power of 2? Base 2?
like, can I pass?
Yep, no problem. Aaron, you with us? Going once, going twice. Oh, yep. Can you turn the 8 into a 2 to the power of something? And same with the 4?
Um, 2 to the power of 12. I think I'm gonna get this wrong.
It's okay. Well, think about it carefully. 2 times 2 times 2 times 2. I could go on forever. How many times do I multiply 2 to get 4?
2 to the power of 2.
Yes, good. And what about 8?
8 to the power. Does it say 2? Yeah.
This is a question mark.
Oh. 2 to the power of 3.
Good. That's right. So 8 can be turned into 2 to the power of 3. 1 over 4 can be turned into, with a negative, 2 to the power of 2. Now that they are the same base, we can apply our exponent laws. This is 2 to the power of 6. All of this can be simplified as 2 to the power of 6. They are the same answer.
Oh, I see.
Yeah. So, I'm going to give everyone else a chance. Take a look at the next example. Using the previous one as a template, would you simplify this for me? And of course, you can't use the exponent laws because the bases are different. Or are they? Give yourself maybe 2 minutes. And this is why I'm also saying it might be a good idea to know your powers with base 2, because you can just sort of pop it in very quickly. All right, copying. The 8 is 2 to the power of 3. 4 is 2 to the power of 2. And 16, probably got a clue, 2 to the power of 4. Which means the top numerator is 2 to the power of 6 times 2 to the power of 8 over 2 to the power of 12. Exponent law, adding exponents, adding the powers, sorry. 2 to the power of 14 over 2 to the power of 12. And then exponent law, division means the exponent powers will subtract. 2 to the power of 2.
You just write 4?
You could. Again, I'm just, you know, the whole point is to show me that you can deal with the exponent laws. I don't mind if you leave it at 2 to the power. As long as it's not a positive, as long as it's not a negative exponent, it'll be okay. Okay, so if you look at the back of the sheet, there's a buttload of these annoying questions. And there's a couple of questions in there where you have to add, like you have to do like 2 to the power of 3 plus 2 to the power of 2. What's the answer? I'll give you 10 seconds to think in your head. The answer is, it cannot be simplified. This, although the base is the same, it's an addition. It has nothing to do with exponent laws. If anything, the best you can do is 2 to the power of 3 is 8. 2 to the power of 2 is 4. The answer is just 12. That's as far as you can go, really. Right? So just be careful. Quick recap. When you're dealing with exponent laws, they have to have the same base. Okay? You may be able to problem solve and turn things into the same base when necessary. Multiplying or dividing, power of a power, those are when you can use your exponent laws. A negative or a zero exponent, we learned last class. And now we've covered when exponents are fractions, how we can deal with it. Okay. Any questions? You probably just need some practice, but I'll take questions if you have. No? Okay.
I have a quick question.
Yep.
So on a test, if it was like a final answer was like, for example, if it was 2 to the power of -2 instead of 2 to the power of 2, would our final answer have to then be 1 over 2 to the power of -2?
Yes, please. I would not
Get
want
it
you
right.
to leave it at
We
that.
left
Yeah.
it as 2 to the -2. We get it.
Well, it's not that it's wrong. However, by convention, you just like how you don't have a radical in the denominator, we typically don't like to have exponents as negative. So try to deal with the negative exponent if you can. The worst you would do is get like a poor form, like the communication mark at the end of an assignment. You might get like a half mark off or something like that because it is not following mathematical conventions. But it's not that it's wrong, it's just not, it's frowned upon, the best I can say. Okay? All right. Quick forecast. Tomorrow, I'm going to cover 3.4 and 3.5. If this wasn't a COVID scenario, I would probably have gotten you to group into like groups of like 3 or even 6 and sort of have some fun making the AKDC stuff hard for you. Anyways, next time I see you, I'm going to get you to look at the transformations of exponential functions again. I'm going to teach you some tips of how you can look at a graph and even figure out the equation. Now you can practice that. And then we're going to draw some more to show that even the exponential functions will follow AKDC to the T. Okay? Once you do that, that's basically it. Okay? Which brings us to me encouraging you and talking a little bit about this test. If you look at the sheet that I provided for everyone, a majority of the course is, or the test is going to be on transformations. You know what? It's better to have something in front of us instead of just listening to me ramble. So, okay, sharing my, here it is. Hey everyone, let me zoom in a little bit. So these are the main topics of chapters 1, 2, and 3. If you notice in chapter 2, Majority of this was AKDC. Yes, we did an inverse function. In the very beginning of the year, we did rational expressions. So putting rational expressions aside, for now, most of chapter 2 is going to be a transformation question, and then a little tiny piece on inverse. Can someone here offer the class a suggestion or an idea of how I could ask chapter 2, all of chapter 2, in a single question? How might I think of a question that covers transformations and inverse at the same time? Going once, going twice. Maybe I might ask you to find an inverse of a function and then transform and then tell me the transformations. Or find the inverse of a function and then ask you to graph it. So things like this that you might want to consider. What else would you want to know? You can see that transformations is a huge part of this test. There are two large sections where transformations occur. And then we just did rational exponents and simplifying. And then we're going to look at more word questions later on. That's tomorrow/Thursday and Friday. Okay? Take a look at what the format's going to be. So let me, I also need to talk about the cheat sheet. Okay. It's going to be approximately 45 minutes, approximately 40 marks. 10 of those are going to be in multiple choice, which means it leaves me about 30 marks for you to do in 35 minutes. 30 marks. Let me write this. Let me annotate it so you have it in front of you. Okay. 30 marks. Let me write it darker. So it's approximately 1 mark a minute. If I give you a word question and it's worth 5 marks, I typically expect you to do it within about 5 minutes. Okay? And I'm going to have about 5 or 6 word questions for you to do. One good way to test yourself is if I give you an AKDC question, right? And I give you like 1 mark for each. That means you should be able to do it within 5 minutes. Can you do some of the practice questions we've done in the past? Go back to it, go back to chapter 2. Can you do a transformation in 5 minutes? That might be a good gauge of where you'd like to be. Okay? Other things you might want to consider. Oh, cheat sheet. To level the playing field, because there are some virtual learners out there in my class that are going to be taking this test at home for them. As much as I'm going to get them to use a camera and put it where their test is, and their phone is also going to be next to them where my camera can see it, okay? There are so many creative ways people could cheat, so I'm going to remove that factor completely and say everyone is entitled to a single 8.5 by 11 cheat sheet. You can write whatever you want here. It's up to you. That's also going to motivate you and encourage you to start studying now. Because as I said, the leftover parts of chapter 3 is just a transformation, which you already know how to do. So you can go back to chapter 1 and 2 and start studying right away. Okay? Number 2, transforming, studying. Yeah, go back and see if you can do so. Maybe you want to focus most of your time on the parts that are covered the most. Like for example, as you can see, a huge chunk of it is going to be in transformations, right? Another big chunk is going to be graphing quadratics with roots and max and min. Now that we've done exponents and exponential functions, now is a time for me to really press you to get a calculator. you are allowed a calculator, so a pencil plus eraser, because you might make a mistake, and a calculator is going to be huge. You are not allowed a phone. If you have a phone, you're like, oh, I don't have anything else. Can I use my phone? I'm going to say no. So you have to write a test without a phone, or without a calculator. You have been warned. Okay? You can come and say, oh, that's not fair. Let me just use my calculator. Let me use my phone. I'm going to say no. And you can think that I'm a dick about it, but I'm warning you now. You can't use your phone on a test. If you don't have a calculator, let me know ahead of time and I'll design one for you. But if you come to me the day of and be like, oh, can I borrow a calculator? I'm going to say no. Because I have to go to the math office and get it, and I can't leave the test while people are writing it. It just doesn't work that way. Please be prepared. Even if you prepared and then you forgot your calculator at home because you were studying so hard, I can't help you. This is your responsibility. Okay? Same thing as bringing a pencil to school. Calculator is your responsibility. Okay. Yeah. So your study sheet, calculator, pencil, pen, or an eraser. I think that's about it. Questions? You as a class, you are my, this is Tuesday, so you are my day 3?
Day 1.
No, you are my day 1. So you will be writing the test on Wednesday. So you have a little over a week, right, to work on it. I highly recommend, here's one recommendation. You already have your assignment where you have to graph, right? You have to create some random function, and you have to figure out your AKDC, and then you have to sketch it for me. Being able to do so essentially covers 2 huge sections of chapter 2 and 3. Maybe you want to use your assignment and really be serious about it so that it doubles up as an assignment, it doubles up as your study, and you also don't have to write it in your cheat sheet because you understand it. Right? I don't know. I could go on and on and on about what you could and shouldn't do, but I'll stop there. Any questions or clarifications you'd like me to go through?
I had a question about the assignment, not the test.
Okay.
So for we don't need to follow any equation. We just need to put down 7 points and then apply AKDC to it. That's it.
Yes. So let's pretend
Parent function or anything.
let's pretend this is my new function. Notice how it doesn't follow any parent function you've learned before, right? From here, let's pretend my a is a 2, my k is a 3, my d is -1, and my c is -5. You will apply the a, and then you will say that the line that you drew is a f of x. And from there, you will draw the k, which will make the function into this. And then you will add this to it, which makes, 2. That's a 2. So that'll be 2 f of 3 bracket x plus 1 close. And the last one is 2 f of 3 x plus 1 minus 5. Get what I'm saying?
Yeah.
Yeah. So that's all I need. You don't need to actually tell me what the parent function is. It could have random points, which means it doesn't really follow an equation, but you just write it as in terms of f, and that'll be good. Anyone else? No? Okay. Then your homework, the answer key should already be up there. The whole purpose of these questions is simply to provide you some puzzles where you can, sometimes second guess yourself, be like, is this the way to do it? And really, really grind through and get you to practice exponent laws, right? It also has a couple of tricks where it's like you can't use the exponent laws because there's additions or subtractions in ways that you're not supposed to use with exponent laws. So it's really going to test you whether you know when to apply them or not. Okay? The answer key is already there. Please give that a shot. And then we'll reconvene tomorrow and we're going to go back into the transformation stuff. We will finish off all of this for exponential functions. I'll show you how to find equations given graphs and vice versa. And then we move on. And just studying, you know AKDC, so it's just studying for the test from now. Yes? Okay. So it's 3:05. You're unofficially dismissed. I am going to use the remaining 10 minutes to take up any questions you might have with the assignment, with previous homework questions, whatever the case may be. Everyone's attendance has been accounted for, so you don't have to worry. If you want to go take a break before tackling this again, you have the permission to do so. Okay? So if you leave, have a good one, have a good night, and we'll see you tomorrow afternoon.